This section 2.2 also has some explaining to do, okay? And I'm going to be very specific with how you need to do your explanations again, okay? So make sure you take some good notes. And the explanations that I require are a little bit different than what the book wants. So just know that if you rely on reading the book to find your way instead of my notes, that's not going to work out real well for you this particular time, okay? So for starters, I'm going to put something on the screen that is in your book. You can either take a picture of the screen or you can screenshot it from your book. I don't care which way you do it, but please, please, please do not attempt to write all of this down, okay? And here it is. It's on page 206 in your book.
I got this.
What we're trying to determine in this section is we're going to be given a relation. Okay, we talked about relations and functions in 2.1. Now we're going to try to see if our relation or function happens to be linear. What that means is the graph of it will be a straight line. Okay? Now, there's conditions that need to be met in order to be linear. And they go through them here. All right? And on the next slide, I have all the explanations that you're going to need to write. First off, the variables can be added, subtracted, or multiplied by a constant. A constant is just a regular number, okay, without a variable on it. So we can add, subtract, and multiply with a variable anytime, and that still allows it to be linear. Okay? Here's some things that can't happen. Variables cannot be multiplied together. And this is why I just talked about that f of d thing. That does not mean that they are multiplied together. That's just function notation. Okay? Also, a variable cannot be in a denominator. A linear can't have a power other than 1. And then the graph is always aligned. So let's take a look at these examples real quick. All right? So here is a linear equation. The highest power on the variable is 1. Or it's to the first power. We don't write it. All right? X and y are both multiplied by constants. There's no x's in denominators. And the same thing is going to be true down here. Even though this fraction and this fraction is multiplied by x, x is not in the denominator. But as soon as you look at one over here, x is in the denominator. You can't have a variable in a denominator and it be linear. There's nothing wrong with this equation. It's going to be a graph and it's a relation and whatever. It's just not linear. Same with here. X and y are multiplied together. X is underneath a radical. Okay? A y is raised to a power other than 1. Okay? So, on the next page, and you can take a picture of this too, and this is not in your book, these are the conditions that need to be met, and this is a summary of what was on the other page. These conditions need to be met in order to be linear. And on a test and quiz, if you encounter an equation that is linear, and you are going to give an explanation as to why it is linear, this is what you need to write every time. And so this is what you're going to have to memorize to decide if something is linear. So in order for an equation to be linear, all 4 of these conditions must be met. If one of them is not met, it can't be linear. So on a test or quiz, if it is linear and you have to explain why, you say yes, it's linear, and then you have to write those 4 things down. And you're going to have to learn them. You're going to have to memorize them. And let's just go through it real quick. No variable raised to a power other than 1. No variable in a denominator. No variable under a radical. No variable multiplied by another variable. Now, it seems like a lot of writing, but there's not a lot to memorize there. You can practice this, and you're going to get a chance to practice this and writing it down and working through that. But these 4 things must be true in order for it to be linear, and you have to use that as your explanation. If you miss some of those in your explanation, yeah, you're going to lose some points. You have to say all 4 of those things every time. Okay? I'm going to take you through 3 examples. Okay? Some of them are going to be linear, some of them are not. And I want to show you what it is that you need to write for each type of situation. Okay? So let's start with the next one. Go ahead and write this down, please. This is the kind of problem that you're going to see. It's going to say, state whether the function is a linear function. Write yes or no, explain. If you leave off the explanation, that's a big part of the problem. Okay? So make sure you include the explanation. And so what will happen, bless you, what will happen is that list of 4 conditions, you'll have to kind of run through in your head every single time for each equation. And as soon as you come to a condition that's not met, you stop and you say, no, it's not linear, and use that condition that it doesn't meet to explain why. If it is linear, then you have to list all 4 of the things and write them down. So in terms of the amount of work, there's less work if it's not linear. Think about it the same way when something is not a function, we use the vertical line test. When we can draw the line on the graph, there's less work than explaining why it doesn't pass the vertical line test. Okay? So after you get that done, we'll work through this one and talk about it. Alright, so in order to make the determination if it's linear, we start with the very first condition. And the very first condition is a variable can't be raised to a power other than 1. Now notice here, this does not mean f times x. This means f of x. It's function notation. You could even think of this, if you wanted to, as y. F of x and y are like the same thing. Okay? So don't think of it as f times x. You can think of it as y equals. Okay? So the first condition is no variable can be raised to a power other than 1. What is the power on y here? 1. What is the power on x? 1. Okay, so the first condition is met. The variables are raised to a power of 1. Okay? The second condition, no variable can be in a denominator. Is this variable in a denominator? Is this variable in a denominator? It would have to be under here with the 4. So no, it's not in a denominator. Is there a variable under a radical? No, there's not even a radical in this problem. Are there variables multiplied together? No. So this is why I was making the distinction here. This does not mean f times x. This is f of x. It's a function with the input value x. So none of the conditions are a problem. This equation meets all the conditions. So therefore it is a function, yes, and then you have to write all the 4 things down. So this is what your answer needs to look like. So again, I will say this again. On a test or quiz, if you want full credit for a situation like this, you have to write all of that. Yes, you have to memorize all of that. You have to learn all of that. All 4 of those conditions must be met, and you need to state it as your explanation. And this happens every year, and this is why I'm going to say what I'm going to say. Inevitably on a test or quiz, you write it down one time for question number 1, and then number 4 turns out to also be linear, and I get people that draw arrows instead of writing it again. Don't you dare do that. No, it is not. It will cost you all your points because you're not writing it down. Yes. Are you having to write it down again? Yes. Do you have to write it again? Yes. In your homework, should you write it instead of copy paste? Yes. Why? Because then you're learning it, you're practicing it, you're memorizing it. It's good practice, right? We talked about exercises in here before. Now let's talk about some other situations. So the directions on the top are the same. Okay, the directions on the top are the same. I just gave you 2 more problems. So write those 2 problems down and we'll talk about them. Let's focus on the first one. Let's focus on the first one. Again, this does not mean f times x. This is f of x. All right. Now, yeah, if you want to think of it as y, you can. So the first one is a variable raised to a power other than 1. What is this power on x?
1.
So that one's fine. What's the next one? Second one down. No variables in the denominator. What do we have here? Okay, so we have a problem. Which means, we don't have a problem. It just can't be linear. Okay? So because there's a variable in the denominator, it's not linear. So my explanation is, no, there is a variable in the denominator. That's it. So there's less work when it's not linear. And you just state the reason that of those 4 things that have to happen, you state the one thing that makes it not happen. If there is more than one reason that makes it not linear, then state all the reasons. That's okay. Now, again, I want to explain this notation because all this means is the function is g, it's named g, it has 2 input values, x and y are input values, and if you notice over here on the rule for g, you see x and y. Right away you should have an idea here. Why not? Multiplied together. We can't have variables multiplied together. So go ahead and write your explanation. Let's see if you get it right. So Dylan's question was, if it's linear, does the order of the four things that we write down matter? The answer is no. As long as you get all four, I don't care the order. Because what will happen is, on a test, you'll be like, all right, I got three of them. What is the fourth one? And you can't remember it. And then all of a sudden it comes to you and it's out of order. That's fine. No problem there. All right. So in this case, all right, and I even circled them for you. No, the variables are multiplied together. Okay? And I circled them because I wanted to point out the difference between this being multiplied together, variables multiplied together, versus function notation. This is not variables multiplied together. There's three topics in this section that we're covering. This is one of them, whether or not something is linear. Okay? The other thing that we're going to cover is standard form of a linear equation. My guess is you haven't spent a lot of time on this before, but you might have spent some time on it. Most of the time when you've dealt with linear equations, you've dealt with slope-intercept form, y equals mx plus b. You've probably spent a lot of time working on y equals mx plus b. Standard form is still linear, but it comes in a little bit different form. And notice here on this case, you have x and y on the same side. A and b are called coefficients. The number in front of the variable is called a coefficient. So a and b represent the coefficients. C is the constant, the term that doesn't have a variable on it, just the plain old number, and it goes on the right. So we have the a term first, then the y term on the left, then the constant on the right. That's standard form. Here's what you need to know about a, b, and c. Okay? This first term has to be a whole number. B and C have to be integers to be standard form. Okay? A must be a whole number, and if you remember your number sets, whole numbers are 0 and positive. No fractions, no decimals. Integers are positives and negatives, still no fractions, no decimals. So in order to be in standard form, there can't be any fractions or decimals. The first term has to be 0 or positive. These other terms are just integers, no fractions or decimals. And maybe somewhere in your notes as a reminder, you write no fractions or decimals. Okay, maybe as a reminder, you write whole numbers are 0 and positives, no fractions or decimals. Maybe as a reminder, you write integers, positive or negative numbers, no fractions, no decimals. How you put that in your notes is up to you, but if I were you, I'd put it in there. I'm going to put up 5 equations. Okay? And what I want you to do, I want you to circle, underline, whatever, the ones that you think are in standard form. Okay? So write these 5 equations down and then somehow indicate which ones you think are in standard form. Okay? Here are those 5 equations. Which ones are in standard form? All I wanted you to do is decide, as the equations stand right now, which ones are in standard form. So, let's just go down the list, okay? Number 1, is it in standard form? Okay, it is. That is correct. How about number 2? No. Why not? Because this can't be negative, right? Yeah. This is okay to be negative. Yes. This cannot be negative. So therefore, this is not standard form. How about number 3? No. What form is this? What's the name of that form? Slope-intercept. That is correct. All right. How about 4? No. What's wrong with this one? Is it slope-intercept? No. Negative x. Okay. The x and y are on different sides of the equation, so that's no good. It's just not standard form. Okay. What about 5? Fractions. Right away you should be like, there's fractions, that's bad. Okay? No standard form. So the only one that's in standard form is number 1. Now let's talk about it real quick. Okay? And then we're going to do something else with those 4 equations. Alright? What is A for number 1? 3. What is B? Negative 4. That's important. Take that sign. What is C? 17. In your homework, you're going to have to identify A, B, and C, and that's how I want you to write it. Okay? Oh, on the next slide, we're going to take those that are not in standard form and we're going to put them in standard form. Now, what I want you to do, I want you to do what you need to do to try to make them in standard form. Okay, you could move things from one side to another. You can multiply both sides by something. You can divide both sides by something. I'm going to leave that up to you right now, but I want those four in standard form. And then after we do that, we'll identify A, B, and C. Just keep in mind, you've got to have the x term and the y term on the left, the constant on the right. So on this first one, the only problem is that this is negative. If this wasn't negative, it'd all be great. All right, we'd be fine. So you can think about this one of two ways. You can divide every term by -1, or you can multiply every term by -1, but ultimately all that does is change all the signs. Okay? So that is the same equation, multiplied or divided by -1, changing all the signs, it's the same thing. Okay? So that's, how many have that one? 5x minus 9y equals 11, with your signs in the right place. Okay, good. This next one. Now I got x and y on the wrong side. So I'm going to move 6x to the other side. And so what I end up with is minus 6x plus y, because y is positive, equals -9. The problem is now I created a situation like this, where this is -6. Well, if I just change all the signs, which is multiplying by -1, then I'll be in good shape. So I got 6x minus y equals +9. How many had that? Okay. This one works the same way. Basically, I just take that and move it over there, and it changes the sign. Did you know that? When you move a term across the equal sign, the sign just changes? Yep, so that just becomes 8x positive plus 2y equals 10. Now we got to talk about the last one, because the last one's a little trickier. I've taught you how to get rid of fractions. Do you remember? What do I have to multiply through by? Nope. Common denominator. What is the common denominator? 15. So if I multiply everything by 15, okay, what's 15 times 1/3? 5. So this is 5x. 15 times 2/5. So the 5 goes into 15 3 times. 3 times 2 is 6. And then the last one, oops, I'll show you here in a sec. The last one is 15 times 7 is 105. So let me show you that one again. So 15 times 2/5. It's like 15 over 1. 5 goes into 15 3 times. That's where the 6 comes from. Okay? Now, here's what it looks like typed out. Okay? So when I brought the -6 over, it was still -9 over here, right? But when I brought the -6 over, it's negative here, and I need to make that positive. And so, since this one's supposed to be positive, I just multiply or divide everything by -1, which changes all the signs, which changes that sign also to positive. Okay? Alright. Let's talk about A, B, and C real quick. A for this problem is what? 5. What is B? C. Okay? A for this one. B. Here's a tricky one. -1. Very good. How about C? A 8, B 2, C 10. And the last one, A is 5, B is 6, C is 105. Okay? Any questions on that? Yes?
How'd you get it -9 when it was positive?
So when I brought this, so on the last slide, let me show you on the last topic that we need to cover are x and y intercepts. Now, you've spent a lot of time working with y-intercepts, but you probably haven't spent as much time working with x-intercepts. Okay, but before we get into a problem, we need to make sure we're on the same page definition-wise. So first off, the x-intercept is a point where a graph crosses the x-axis, or intercepts the x-axis. Okay, that's the key thing here. What's true about any point that's on the x-axis? What about its coordinates? Every point on the x-axis has something in common.
Yeah, it's on the x-axis.
Yes, correct. It's on the x-axis. What about the coordinates of the points that are on the x-axis? What is true about all of those points? Nope. Think about some examples. Think about some points on the x-axis. Give them some coordinates. All the points on the x-axis have something in common regarding their coordinates. All right, let's give you some examples. Let's make some examples real quick. Okay, here's a point, here's a point, here's a point. Let's call this 3, 0. Let's call this one -2, 0.
Oh, they all have 0.
Where?
For the y.
For the y. The y coordinate of every single point on the x-axis is 0. Okay? The y value of every single x-intercept is 0. In order to lie on the x-axis, y must equal 0. So when we're trying to find the x-axis, the x-intercept, we're just going to plug 0 in for y, and we're going to simplify. Okay? What do you think the next line is going to say? Y-intercept is a point where the graph crosses the... Y-intercept is a point where the graph intercepts the y-axis. So now we're talking about the graph crossing the y-axis. So yeah, what's true about every point on the y-axis? X equals 0. Okay, so there you got your next line. So if you think about it, and one of the ways that I kind of remember it, in terms of what value is 0, it's the opposite of the one we're looking for, right? So like, if I'm looking for the x-intercept, then the y is 0. If I'm looking for the y-intercept, then the x is 0. So where the 0 goes is opposite of the one we're looking for, right? And that's the way I like to think about it. That's how I keep it straight. So next we're going to go through an example like the problems that you're going to be doing, okay? You're going to have to find the x and y intercept, and then you're going to have to graph it. And I'm going to take you through all the steps. So this will be a good example when you get to it on your own, okay? So here's the example, okay? This is what it's going to look like in your homework. It's going to say graph the equation, whatever it is, or it might say graph the given equation using the x and y intercepts. So the first thing you have to do is find the x and y intercepts. Now here's how I like to set these problems up. I like to create a table of values, okay? And I'm going to start with the x-intercept, and that means y equals 0. So, how do I figure out what the x value is that goes with it? How do I find this x value? Yeah, Max? Isabel, you think you got something?
Then you plug 0 in for y
Yeah.
and try to solve it. And figure out your x's.
Exactly what you do. So to find it, you plug 0 in for y, because that's the coordinate we know, and we solve for x. So go ahead and do that. Find x. So what is 5 times 0? Negative 5 times 0? Negative 0 minus 0, nothing. So 2x equals 10. What's x equal? 5. Which means 5 goes up here, and my x-intercept is 5, 0. Okay. How many have that? Okay. So then what do you think I do for the y-intercept?
Same thing.
Except,
You switch it.
where does 0 go now? Goes in for x. Okay. So to find the y-intercept, I've got to do the similar process over here, but instead of plugging 0 in for y, I plug it in for x. It's like this. So go ahead and solve that. So another way to think about this over here is when you plug in 0, this term just goes away. Notice it's just 2x equals 10. So the same thing is going to happen over here, except be careful. There's that minus sign still here. You don't want to lose that minus sign. Okay, so what is y going to equal in this case? -2. So it's negative 5y. Y equals -2, which means this is -2. Means the y-intercept is 0, -2. How many had that? Okay, good. So then all we have to do is graph it. And we're done. Okay? So, go, and here's my graph. X-intercept is 5, 0, so I go over to 5, 0, and I put a point. The y-intercept is 0, -2, so I go down 2, put a point, connect the dots, since we have an equation, and I get a line. So those are the 3 different topics that we cover. So there's 3 topics in this lesson. Is it linear or not? And the 4 reasons what makes something linear. Okay? Standard form of a linear equation and putting it in standard form and identifying A, B, and C, and then finding the x and y intercepts and using those to graph with. One other thing I want to mention about graphs. Do not freehand your graphs. You need to either use graph paper and Notability, or you need to grab a grid from the internet somewhere that's already set up for you, and you can label it and tweak it as you need to. But your graph should not be free-handed. We have the tools to make them look really nice. Okay, so please do that.